Christina. Good. All right, then for the grand final today, we have Michael from Ulster University talking to us about designing for more natural conversations. Now, this is something that is a topic that's also quite dear to me, because that's something we have a riddle that we have tried to cope with over the years. Big part of our team is also quite interested in how you can actually reach the point where a virtual assistant talks with you in a more natural way. So, Professor, it's a pleasure to have you here, and the floor is yours.
Thank you. So, as you can see, my name is Michael McTear, and I'm from Ulster University. I'm actually retired, but for my pains, I'm still working a lot in this area. When I first started many years ago in this, we used to call it dialogue systems and spoken dialogue systems when we were able to introduce voice into it as well. But it was very much a fringe area. People in my department sort of laughed it off, said, oh, that'll never work. People who used deployed systems, like in call centers, quite often complained that they were very clunky and didn't work and wanted to talk to a human. But when you fast forward now to a few years ago, we had Siri, we had the launch of Amazon Echo, Google Assistant, and now really everybody uses voice. In their homes, people have smart assistants, they have smartphones that have voice assistants. We can talk to them in our car and so on, and it's really become a part of our everyday life. But like a true academic, we're always looking for new things. That's what actually keeps us in work. And so what I want to say is that we really need systems that are actually even more natural, more advanced than what we have, and that's what I'd like to talk about today. This is just a brief outline. I'll say briefly what I think a conversational system is, give a brief review of what we can do with current systems, and then motivate the reason for trying to make them more conversational. And there are a couple of different approaches I'll look at. There's the typical handcrafted design that I expect most people here are familiar with. And then there are methods, new methods that have been developed within what has come to be called conversational AI. Now, although I come from a country of musicians, we've U2 and Van Morrison, Snow Patrol and so on, I promise I won't sing a song at the end of this. So a conversational system allows you to interact in a conversational style, which quite simply is taking turns in a conversation in order to, well, either to accomplish some sort of a task or simply just to engage in a social chat. And from the point of view of technology, this is possibly an easier way to interact than with conventional means. Though what I say is it's possibly easier because there are lots of pitfalls and these systems don't always work as expected. Just a little brief aside, the word voice is used very liberally. I mean, the name of this conference, people talk about voice first. We say that voice is the future and so on. But in a way, voice is a modality. And it doesn't necessarily mean that when you have a voice system, you actually have a conversational system. So when you speak to your smart speaker, for example, it's not really a conversation. It's just one command or one question and one response. Conversation, on the other hand, is a style of interaction, and it provides an alternative to a direct manipulation interface. And it should be more natural and more intuitive. For example, if you want to say the destination of where you're going to, you don't have to go scroll down through a great big list. I found when I was filling out my forms for vaccination and so on, And for entry into Germany, I had to go down a list. I couldn't find the United Kingdom for quite some time, which is where I reside, despite also having an Irish passport. It would have been easier just to have said United Kingdom. So it is potentially an easier way of interacting. However, if you want to get to more advanced conversations, then you really have to go into a much more complex technology, which we do call Conversational AI. Now, as I say, conversation has now been incorporated as a main challenge within AI. This is a quote from the authors, the developers of the Google Mina chatbot. I'll show an example of that shortly. But on the other hand, and this is from people who were the organizers of the Alexa Prize, which again I'll talk a little bit about later on, it's still a very, very challenging area within AI. So although people see conversation as being a very simple thing, and my early work was actually on children developing conversation, and I could show quite advanced conversations from the age of 3 or so onwards. Nevertheless, for AI technologists, it's one of the most challenging. Some people say it is the most challenging area of artificial intelligence. So what can we do with current systems? Well, typically people divide it into two different types of system. Those that are trying to accomplish a task of some sort, like scheduling a meeting, ordering a pizza and so on. There have been deployed systems, we call them voice user interfaces, that have been around since the early 90s. Now, of course, they're enhanced by sometimes having a visual interface as well. And that technology is fairly well developed. The other side is where you have what is sometimes called chit-chat or simulated conversations. That actually goes back a long way. Everybody talks about Eliza, the first conversational chatbot. Technology was a little bit different from the way people develop chatbots nowadays. We have the Loebner Prize, more recently the Amazon Alexa Prize. These are in some ways used for entertainment, but they could also be used for various social purposes, such as providing companionship and support. This example is from Mitsuku. It's actually used, it has actually won the Loebner Prize 5 times now. It's in the Guinness Book of Records, developed by Steve Warswick. It's been renamed recently to Cookie, and it actually was in a competition with Facebook's chatbot and actually seemed to perform better on the human evaluations. Now, I want to show just a couple of examples. Now, that did work earlier on. Okay, that's what was being said. I thought that mightn't work. So the user says, what's the temperature like at Mount Everest? This was talking to the Google Assistant in this case. And the system said the temperature there is -14. So that's the sort of thing we do with our smart speakers. That's sometimes called a one-shot exchange. The conversation doesn't really go any further. You ask a question, it gives an answer. You ask a different question that's totally unrelated, gives a different answer, and so on. In that case, this is what's called user initiative. The user controls the dialogue. But you have to do it very carefully. You can't hesitate. You have to say everything in one go. And because you can ask virtually anything, it requires extensive speech recognition capabilities to be able to understand what you say. That's the voice part of it. And also natural language understanding to actually interpret those words. Well, then beyond that, of course, it has to search for an answer as well. So it's really quite a complex technology. There are developments of that because you can now, with both Amazon and Google, you can ask follow-up questions. So you could say, what about Frankfurt? And it will tell you then some related answer about Frankfurt. Now, actually, a few years ago, when you did that, it would maybe say something like Frankfurt is a city in Germany, and it wouldn't actually see the connection between the second question and the initial one. There's various technologies for doing this called, for example, contextual slot carryover, where we have the different slots. I've marked them in color there. We have a location slot, and we have a topic slot, temperature. You could potentially also have had a time slot. So you could have been saying, what's the temperature like at Mount Everest next week? And then you could say, perhaps, what about in a month's time, and so on. So it can carry over it identifies the different slots in the query, and then has a way of actually recognizing whether the subsequent query is asking about one of those identified slots. So it's an interesting technology, but that's about as far as it goes. And if you were to ask your follow-up question maybe 3 utterances later, it normally wouldn't actually work anymore. Although people are trying to develop ways of maintaining the context over a number of turns. Now there again, this isn't working, so I'll just... To be fair, I've played an Amazon one there. This is where somebody is asking what's called a slot filling dialogue. In this case, it's actually to plan a trip. And the technology used here is what is sometimes called a frame, where you have a series of slots to be filled at the beginning when you say open plan my trip, which is what the gentleman from Alexa said, or from Amazon rather. All of the slots have unknown values, and so the system then simply just goes right through the different slots from the beginning to the end, and asks the questions, gets the answers, and then that's it. The interesting thing is that if you actually ask for more slots at the very beginning of the query, so here we're asking about the city of departure and the city of destination and the date all in one go, the system will then only ask you about the time of the departure. It won't go through the other queries. Whereas if you had one of the typical conversation flow diagrams, it would be very, very, very difficult to actually implement that. It might actually ask the questions all over again that you'd already given the answers to. So those are 2 technologies that are very well developed. But what is much more difficult is what has been referred to as open domain dialogue. Not just open domain, but multi-turn dialogue. And there are various solutions that have been developed by the large companies. This is an example from a couple of years ago from Google. It's actually not a voice system, it's text-based, as are all of these, in fact. But you can see it's able to, in this carefully selected example, engage in quite a long, in many cases they are very long, conversation about any sort of domain. And there's very, very advanced technologies used in order to do that. Facebook have a similar system called Blender. They've demonstrated that it was better in performance than Google. Microsoft have a Chinese system called Shuais, which in some examples people have actually talked for hours to. And Google this year have released another system called Lambda, which is even more advanced than any of the others. So the thing is then, how do we get to these? How do we actually get these to work? And what's the promise? What are the challenges? And what are the technologies behind them? Well, first of all, to motivate why we actually want to go further than what we have at the moment. In various areas, conversational commerce, for example, you might want to be able to discuss a product, not just ask what's the price and so on, but you might want to discuss in detail various aspects of the product. The other 3 applications are ones that I'm personally involved in various projects. healthcare applications, talking to somebody about their health, not just simply getting a straightforward diagnosis, mental health support where you're going into counselling, and care for older people, another project I'm involved in, where you're supporting healthy and active aging. Here we want much more than just one-shot exchanges or slot-filling dialogues. We want to be able to engage in a normal conversation the way people actually do as human beings. So the sort of requirements then are much more extensive. We're going to be able to have follow-up questions, which we have to some extent already, to be able to deal with clarification requests. So if the system was to say, for example, what sort of food are you interested in? Say it's a request about restaurants. Can the user then say, well, what are my choices? Most systems you couldn't really do that. That would actually go outside the script. Do you allow corrections by the user where they say, no, sorry, I didn't mean Stockholm, I meant Oslo. A change of topic where you change the topic altogether, requests for help. Lots and lots of things that occur in natural conversation. How can we actually develop and include those? How do we actually then do things that the system should do? Where if it doesn't understand, does it simply just collapse and say, the way most systems nowadays do, sorry, I can't understand that, please try again? Or will it initiate some sort of sensible clarification request? Will it actually offer guidance in a proactive sort of a way, saying, well, look, sorry, I don't know the answer to that, but you could ask about this, making suggestions, detecting and repairing various types of miscommunications. And in order to do that, it needs to make use of lots of different contextual information that systems normally don't really. It needs to know about the previous dialogue context, for example, maybe not even just that dialogue, but dialogues that were held the previous day, the previous week, previous month, which we can do. We can say, I remember what you were saying last time I met with you. Knowledge about the dialogue partner, we sometimes call that user modeling. Knowledge about the external environment, what's going on in the outside world, all these different sorts of things. How can these be brought into a conversation? Now, there are basically two different approaches. We can boil it down to two. The traditional approach where the dialogue is totally handcrafted, and that can work quite well. We have a little dialogue here about booking in a restaurant, and the dialogue will follow this path. There could be more branchings and so on, but basically it follows the path. And there are lots of good reasons why you'd want to do it that way, because as the designer and the developer, you have control over the dialogue, and it's not going to go off in some sort of way that's unexpected. But the trouble is that once you develop a more complicated dialogue with all the potential deviations from the happy path, as we call it, it becomes really, really complicated. And this is a real example from a system. That's only 6 pages of the script. There were, in fact, 300 pages in this particular. It was more to do with sort of fault finding and repair and so on. So it was really quite a complicated interaction, but it was a commercial system. I'm not going to say who did it, but you can see that once you have to try and maintain and develop that, it really is going to be quite a nightmare. Now, just looking at some solutions, Robert Moore at IBM, in his book, Conversational UX Design, proposes a design framework for conversational systems. So these are still pretty much handcrafted, but he takes examples from the area of conversation analysis, which was a sociologically motivated way of analyzing conversation. And he devised a series of, 100 patterns that describe different conversational activities. And these can be then put together so that rather than starting with a blank sheet, you have these different patterns, and you can then put together a handcrafted conversation, but is motivated basically by these theoretical this theoretical background. So that would just be one of these 100 possible patterns. To make that a bit more concrete, that's an example of how it would be used. So utterance number 1 is an inquiry, and then we have an answer, and then we have a repair initiator, and utterance 4 is the answer to that. Then we have a further repair initiator, and we have a further answer, and then a sequence closer. You would have to look at all the different ones to see how that can all be combined. And in the book, there's an example of the system, which is called ALMA, where there's a dialogue that goes over about 90 different turns that's built up from these different patterns. So it's still very much handcrafted, but there's a sort of theoretical basis to the conversation flow that is designed. Another approach, which has just been recently developed by Amazon Alexa, is called Amazon Conversations. And here again, the developer starts with sample dialogues, either those that have been recorded previously or ones that are made up, and annotates them. But then that's fed into an engine, basically a deep learning based engine, which expands these dialogues into tens of thousands of variants, so that you don't actually have to manually, as a developer, work out all the different routes that the conversation could go through. The system actually proposes these. And there's two different aspects to that. First of all, the dialogue flows. It can be expanded into lots of variants. Up to about 100 dialogues, for example, looking at all the different variants on which the flow can go. And then the dialogues, the actual phrases, the entities that are used in the dialogues can be enhanced with all the different variations. And so you end up with up to about 10,000 different dialogues. And these can then be used to train a model which then can be used. Now, I haven't actually seen that working in practice yet, but that's the basic idea, and it improves the robustness of the dialogue management model, and also means that the developer doesn't have to code every possible path. There's a reference there to more detail on that. Now, that's handcrafted dialogues. If you're in the academic world nowadays, you don't get anywhere in dialogue technology if you don't use data-driven, statistical-based or machine learning-based models. And in fact, most of the time they start their talks by running down. The handcrafted method has not been maintainable anymore. One particular approach uses what's called reinforcement learning. Now, reinforcement learning has been used very successfully in areas like board games such as Go. There was the famous case where the system outplayed the master of Go. I can't remember his name, but anyway, it defeated him in a series of competitions. And the idea here is that a dialogue is rather similar to a board game because you're taking turns in it. It's not competitive, of course, so it's slightly different. But at each point in a dialogue, there can often be a choice as to what the system should do. So in a very simple example, the system might want to confirm the user's input or simply just move on. So there may be a choice. The thing is, what choice should it make? Now, in the handcrafted approach, quite often there would be considerations like the speech recognition result was very low. So there would be some sort of rule that would be devised saying if the recognition is low, then ask for confirmation. Otherwise, just go on and see what happens or whatever. But here what we do is the system actually learns through multiple interactions, tens of thousands of interactions, either with real users or normally nowadays with a simulated user system. It then learns against an objective function, such as whether the task was completed successfully, or maybe a user satisfaction metric. It learns what is the optimal policy for completing the dialogue, having taken the best choice at each particular choice point within the dialogue. So that's what learning a dialogue policy is. Now, the thing is that is quite that is based on feedback from multiple interactions. The problem is actually getting the multiple interactions. As I say, you can use user simulators, but there's also been some work that has shown that that's not as reliable as using real users. So there's a problem there. And the other problem is that optimizing the policy, this very sort of mathematical part of it, quickly becomes intractable. And so most systems only use a very, very small dialogue situation, like, for example, the one for planning the trip that I showed earlier, where there's 4 different parameters that have to be resolved. But even so, that can become very, very quickly out of hand. When you're taking into consideration, you can have speech recognition errors, and so different paths in which the system might have to follow. So reinforcement learning is quite interesting, but there are lots and lots of technical challenges still to be resolved. Because as you saw from that previous diagram, a dialogue system can actually follow so many different paths that it really does become intractable. Now, the other main, and this is really the state of the art in research, is what are referred to as neural dialogues. And so here you basically take an input, feed it into the model, and produce an output. This is sometimes called sequence-to-sequence mapping. It's been used very successfully in situations where, for example, you have some sort of input, like, for example, in an email, and there's a suggested output. It's also used quite widely in machine translation. And more recently, it has now been applied in dialogue. So a little bit more technically, what you basically have is an encoder-decoder architecture. So the encoder simply just takes the input and processes it. There's been a lot of different ways in which that's done, but with typical a type of neural network, nowadays they use ones that are using what are called transformers with attention. I'll not go into the detail of that. But what they do is they create a representation of the sequence, which is called a context vector, and then that is used then to generate or decode the output using typically a pre-trained language model. There are these enormous language models from OpenAI, like GPT-3 and so on, and they will generate a response. And that works quite well, except if you think of the slide away back about context. The context is usually very, very short. It usually is 2 or 3 utterances back, and it becomes computationally quite difficult to actually go further back in the conversation. Although people are working on that, it's very much at the research frontiers. Now, the trouble is that although that works fairly well for a certain number of examples, it does require large amounts of training data to actually train the systems, and vast computing resources as well. And that's actually getting beyond the reach of small university departments that don't have these resources. Some of them are open source, but a lot of them aren't. And so you really have to work in Google or Amazon or Facebook, Microsoft and some of the others if you actually want to do this research anymore, which is becoming a bit of a problem for lots of us. The systems, as I've actually already mentioned, don't have an explicit long-term memory. So you might have a system where the dialogue goes something like, what's your job? I'm a doctor. And then a few turns later, so what do you work at? I'm a bricklayer. It's totally forgotten that it had told you before that it was a doctor, because it's coming just from data, and it's actually using some sort of data that generates that response, and you may get lots of inconsistency. So you don't really want that to work in a commercially deployed application. Another problem which may not sound so serious, but quite often it simply just produces very bland, uninformative responses, such as just saying things like, that's great, or I don't know, or okay, things like that. And the reason for that is that they have high probability in the data, and so they're generated. And again, there are ways of working around this, but that's quite often a problem, that you don't actually get a sensible response out of the system, and simply just one of these bland outputs. And even worse, sometimes depending on the training data, the responses can be inappropriate, rude, or offensive, sometimes racially and gender biased, or even unsafe. Examples were, for example, somebody said, oh, I'm thinking of taking my life, and the system says something like, well, go ahead, which really is not what you would want. One of the ways in which people are trying to address some of these issues is to actually combine the two different approaches, and so to take a combination of the positive aspects of handcrafted rule-based systems, and then some of the positive aspects of neural generative systems. And one example of that, you can find more detail if you actually go to the paper, is the system called Alquist that was developed in a university in the Czech Republic, and it actually won the Alexa Prize this year. And it uses a combination, as I say, of handcrafted and neural generative models. What they do is they represent the most common dialogue paths as handcrafted dialogues, and then when something goes wrong, they use a generative model to handle topics that are out of domain or that haven't been foreseen by the initial design. There are lots of technical issues there. First of all, you have to be able to recognize that the input is out of domain. So there's the issue of out of domain recognition, using a classifier basically to do that. And then you have to find a response that is actually going to be coherent within the dialogue. These systems would be trained on large dialogue corpora. So that's one particular way in which this has been addressed. But it's still very much in the area of research, and certainly quite far from commercial deployment. So one last thing to wrap up. Last night, I listened to a workshop, well, half of it because it was at Stanford University, and so they were operating in Pacific time, and when they got to lunchtime, it was time for my bed, so I sort of heard half of it. But there's a project being developed at Stanford called the Worldwide Voice Web. And so the idea behind this is to actually develop a technology which would be complementary or possibly an alternative to Google and Amazon and the others, in that it would be open, both for developers and users. It would also preserve privacy, which is an important issue, because we heard earlier about how a lot of our data goes way off somewhere we don't know, and is used for all sorts of other purposes. Technically, it offers various advances as well. So one aspect of what they're trying to do is to develop pre-trained models. A simple example would be for restaurants. At the moment, people just develop their own system, and they're all very, very different. But the idea that is being proposed here is that you would have a pre-trained restaurant model as a general sort of generic system, and each restaurant would then simply just feed in its own information, like its URL and its menu, and they could then generate from that a standardized restaurant dialogue, which again would be a lot easier then for people rather than having to work from scratch. And the third aspect, which again people have been mentioning here, was multilinguality. Amazon really only supports 8 languages at the moment. The Stanford group are hoping to support hundreds of languages. They were illustrating this with Africa, where there are something, I think, like 10,000 different languages spoken. Now, they'll not be able to do that in the short term, but they're wanting to move towards having a greater degree of multilinguality in voice-based systems. And so I think that I've given a reference there. I think that's a very interesting development. It's very, very talented people working on it, and it'll be interesting to see how that develops over the next few years. They've just applied for additional funding to take it further. So just to wrap up then, some takeaways. As I've mentioned, there's a lot of activity in conversational AI, but there's still a long way to go, which keeps us all in jobs. Research is focused to a large extent in the academic world on deep learning. You won't get into a conference now unless your paper's about deep learning, or you won't even get into a journal. But really we need to look at hybrid approaches, and people are starting to do that. The other thing is that a lot of the work in research is very much technology driven, but again, as people have been saying here, there's a need to focus on user involvement, UX, as well. We're doing this in some of our projects. We have a lot of time devoted to getting the requirements initially, where we have sort of working groups and living labs and so on to try and see what the people actually want, and then marry that in with what the technology can currently provide. And in fact, there are a lot of conferences that have been developed recently. There's one called QE, which was developed originally by people from Dublin. There's another one called Conversation. It's a workshop that was initiated by researchers in Norway. And then last year there was the European Chatbot and Conversational AI conference. They're holding it again next year as well. It was online last year. I think it'll be hybrid next year. And these are all focusing on this very, very important aspect of user experience, bringing together original research in HCI and trying to combine that with the work that's been done in AI. So with that, I'd like to just propose some light reading. This is a book that I wrote that came out just last year. And it covers some of the historical development that I sort of slightly hinted at, and then the different phases through the statistical and neural type dialogue as well, methods for evaluation, and some of the, well, at that time, the most recent developments. Of course, even since then, there's been more and more has come out. But it does cover a lot of the aspects that I've been talking about here. So thank you very much for listening, and I hope that's been useful, and I haven't kept you too long from the subsequent activities. Thank you.
Thanks a lot. It was really like great presentation. I think really deep insights. I think this is really something now for the roundtables. I think it's really worth to get like, deeper in it. I think, you went really deep also into technologies, where are we moving? And I think when we think about, I also like the last part that you said, we have to bring together research on the technology, research on the UX side. That's actually also what we are currently doing. We have invested into an own research hub, which looks more on this UX part, but I think it's important to bring them together. And I think the applications you mentioned, I think that's also something great now to look in when we discuss about this. Conversational commerce, for example, I just recently heard a very interesting podcast which says, what makes a great salesman, right? A great salesman has to listen well, has to understand very intricate subtleties. And the things that you here presented is like moving us towards actually being able to understand it at some point. These little subtleties in conversation that humans are able to figure out. And it's not only about conversations, right? It's also about your body language, everything around you tells the salesman, well, he likes that suit better than that suit, for example, right? Yeah. And then the health applications, I think it's also a great case. So I think we have the two